Hey, John here. Somebody put some issues in the repo for the TMS 118, the VDP board, and we talked a little bit about them on the Discord recently. If you go in here and click on this, you see there's three issues. One of them I actually made myself. I made it just a little while ago, right before I recorded this video, which is to provide another way to monitor the IRQ for the This is a problem, all right? I'll talk about this in another recording. I've introduced the issue already, and we looked at some timing, and there's an issue that has a race condition on the VDP. There's a simple solution, but I think I'm going to make a modification to the schematic, and we can also hack a wire onto the board quite easily to fix that problem. I'll get into the more detail later. Anyhow, these two are pretty simple changes. If you have not yet built a VDP, you probably want to know a little bit about these two things. All right, so Dino Eagle chimed in with two things. Number one, there's a capacitor on the VDP board that kind of sticks up a little bit far. And the problem is, if you want to put the flash programmer on top of the VDP, it won't fit because the C3, which is a 470 bulk filter cap, it's a nominal cap. The thing will probably run even without it, by the way, but it's probably better to keep it on there. When I was doing the testing on a breadboard, I used it. It improved things a little bit, but on a breadboard with the long wires and everything, that's a worst case scenario. You need filtering. On a nicely made circuit board, it may not be as critical, is my point. So even if you can't find a 470, you can put a 330 or whatever. Just something in there would probably be nice. 100 microfarads or more would be fine. However, the part that I chose in particular sticks up a little bit far. And what does he say? It could be his soldering. It turns out what did he had an alternate part. He couldn't get the part that like I said, these are nominal. Any junk box, just grab a radial filter cap of 100 to 470 and stick it in there. You'll be fine. Make sure you polarize it right. It has a plus and a minus on it, right? Just don't get one that's really tall if you expect to put something on top of it. Let's go back to this thing and look at the picture. It's this sucker over here. All right. Now, when I talk about the parts, these down here, here's where I got all the things here. Here's the BOM for the DigiKey part numbers and stuff like that. So the 470, I don't know, maybe they're out of stock of this number here. Why aren't these links? Who made this website? Who's the dingus? Now I actually got to go over here, and I got to go DigiKey. Actually, Google knows darn well who DigiKey is. You just put a part number in there, and it will be found. Okay, so these are the parts that I used. And, like I said, this is nominal. Get anything and stick it in there. You'll be fine. Or even boot it up with nothing at all. It probably will work with nothing. Okay. See how this thing is built? It's taller than it is wide. All right. So it sticks up a little bit. If you get his what is it here? So that, again, that's this part here, and it sticks up pretty high. If you use his alternate part, what has he got here? It's tall. He said, here's another one. And I just placed a DigiKey order like today. So he says, here's a shorter one that is similar specs, yada, yada, yada. He probably went and did 10 tons of how many, does it have the same rating? Look, I just threw in a 470 I had lying around in the shop. And then I found, I bought on DigiKey years ago, and I just gave you the number, but just to have full disclosure. He says, oh, by the way, here's a link to one that he tries, or he recommends, which is, as you can see, this is an approximate picture, et cetera, but it's supposed to be stubbier and shorter, is the point. So I went ahead and ordered one of these. I'll go ahead and measure it up, make sure it works okay. I guess we can have a look-see at the data sheet while we're here and see what's going on. Whoa! I see we have both English and what is that, Mandarin? I don't know what it is. Anyway, I can't read it. What does he got? He says 9 to 25 millimeter. Well, 25 would be really big. And you can see there's a little stubby jobber in there. So what did he say? I want the 470 MEF X 8x9. So there'll probably be an 8x9. It's probably like the size. Oh, boy. The yada yada. Frequency. All this stuff about. Okay, so the L. 470 8x9 size. 8x9. Don't know what that means. All these different sizes. Okay. Somewhere it's just D by L in millimeters. So that's 9 millimeters. That's actually not very stubby. But 9 millimeters. Are all these 8x9s? Oh, here's a bigger one, but that's probably not this one. 8x9. Actually, DigiKey might have a note about how tall it is in here. Height with all the fun stuff. Maximum height is 10 point. It's a whole centimeter high. It's not this one. It's probably 9. Because the thing is, when you buy a capacitor, see this jacket and everything, and it's got this rubber thing on the bottom? If the capacitor is going to blow up, this is the vent, okay? Well, it has two things. One, the top has usually has a crisscross in the metal, so the metal, if it's going to crack, it'll crack up there and it won't blow out the side and create a big problem. It'll go out the top, or it'll release the rubber thingy out the bottom. Point is, it's probably 10.5 millimeters high. And then why don't we go and see what my old one was? What did I have? Where is it? Here it is. Watch it be the same size after all this crap. Which one is it that I used? So it's the M010 471 M010ST. So let's get this on the screen so that it fits. Okay, so there'll be some sort of, that M010 probably tells you, that's the 10 volts or something. Capacitance type, the SK packaging, lead configuration, SK. Maybe they're all the exact same, I don't know. What's L? Characteristics. Here we go. 470, blah, blah. That's not the number. I need that one. ONOST. Here it is. So this one says length 11. So this is a whole 0.5 millimeter. Well, maybe we could have found a better one. Anyway, there's two ways to deal with this issue. One is, at least that other capacitor is a little smaller. And I think Dino Wiggle, which is what he goes by over here, says it's only off a little bit. Description showed the alternate part and specified as having the same installed standard seated height. Blah, blah, blah. In any event, bottom line, he found one that's allegedly shorter. I ordered one. We'll find out how much shorter it really is. Bottom line is, and if you look in here, I don't know if he did it in here or a future comment. He says, there he goes. On the programming board, and this is the key, all right? If you haven't built your stuff yet, if you make the programming board and you use the same header that I put on the VDP, then that will set the programming board up much higher than it is anyway. Then, even if you have a bigger cap, it will fit. All right, so that's the point. There's two ways to fix this. Get a shorter cap or use a different connector when you build your programmer so that it fits. So here's my retro, here's the programmer, and here's the VDP. So let's look at what he's talking about. First, note this. When I built my VDP, I didn't have the right connector. This connector fit in the same footprint, so I went ahead and stuck it on there. My point is, my VDP, you can't put anything up here no matter what, because it'll knock into this. connector here. I should probably pull it out and replace it. I do have some new ones that would fit. I should probably do that at some point. But if you do have the right angle one, it is a lower profile. It should fit. The capacitor is the thing that he's talking about here. And if you put a programmer, if you want to try to put the programmer on top of this, what I'm going to do is I'm going to just put it in over like this so that I can show you what I mean, since this is obviously not going to work anyway. And it still doesn't fit. All right, so you can see that it gets hung up on this big old capacitor sitting right there. Okay, so he suggested maybe these would work better. Now looking at them, I can see these do look smaller. And here's another VDP board that I didn't put together yet. Maybe this will be my final build. That one does look like it's a little bit smaller. I don't know. Maybe, maybe not. I don't know. To my eyes, So, okay. If you put your programmer board on top of this, I don't know how well I'm going to get this on the camera. It's still, it's hard to do this on a black background. Here. If you put the programmer on top of this, you can still see, I'll do it next to it like this. You can still see that capacitor is a wee bit on the high side. It might fit a little. It is lower. It is a shorter capacitor than the one that's on my board. And it'll just about barely make it. But you know what? And I will update the parts, because the one that I used is out of stock. DigiKey anyway. I'll change the part list to use this guy, to use this one here. What is this? This is a 470 microfarad, 16 volt. That's perfectly fine. Now here's the other thing he talked about. This header here. I don't know if it's better on black or white, whatever. We'll keep the retro paper here. So here's the deal. When I built this programmer board, I wasn't thinking about what came next. I'm just making this up as I go, people. So I just stuck on a regular 40-pin header that I had lying around and stuck it on the old retro, and it's okay. Now, it's actually a pretty tight squeeze on the retro board as it is. These oscillators can stick up and hit the bottom of this board if you're not careful. I very carefully trimmed like almost a millimeter off the leads of these before I stuck them in here to make sure that they wouldn't stick up too far. But this thing fits nicely on the retro. But you know what? It would fit better. Here's a blank board of the programmer board. If we stuck the tall pinned header in here instead of the short low profile one, this on the retro board, then you can stick your VDP on top of the programmer without any problem. This will fit very nicely like this. Okay, that shouldn't be a problem at all. Okay, so you could do this type of a thing. I mean, it's going to clear it anyway. All right, even with the ribbon cable connector on here, you got plenty of room. Plus, you can always do it the other way around if you wanted to, because this connector stands up higher. So you'd end up with something like this. I got to stagger it for that RCA connector there. Let's get this. Oops. Move it down a few pins. I guess that's one benefit of having the connector without that shroud around it in your way. We can cheat and purposely misalign these things. So if I put the programmer on even my board with the full-size big cap on there, this fits very nicely. Okay? You know, of course, you don't have to push it all the way down either. But there you go. That's a good idea. So I'm going to change the part number for this header, and I'm not going to tear this thing. I'll pry this off gently with a screwdriver, because I don't want to go and do one of these twisty moves and then bend up all these pins, which is inevitable if I try to pull it off of the VDP. Don't do that. So anyway, all right, so I'm going to change the this is actually the Pi one. this header over here, okay? That way everybody can avoid this problem in the future. And I'm going to spec a cap that you can actually buy if you're going to order your parts on DigiKey, and that is a little shorter than the one that I used in here. All right? So what is the other issue? These are the programmer tabs here. Let's go back up to the issues. What else did he say? Now, I don't know about this one. He did talk about it. He says, the frequency of the oscillator changes a little bit depending on the load capacitors that are on the crystal. And I specified, what did I specify on there? 27 or something. I think I put a 27 puff in there. And he suggests if we up it to 43, the oscillator will run at a different speed, which is probably a better thing because the color's a little bit off on the VDP, as you know. All right? It not only is the voltage too high, the frequency is a little off. So the reds aren't very red, and all the colors are just a little bit wonky. But I would argue that's part of the charm of the retro era with composite video. Nothing was ever right, which is why NTSC, which is the name for composite video, one of the technical names for it. So, jokingly, we all said it stood for never the same color. And it's because of all these little subtle problems. So for before and after reference, here's my retro board in the VDP now, running my prototype as it currently stands of my breakout game. And these are supposed to be red and orange and green and yellow. And there's a little green in here, and there's not a whole lot of red in this brown that's supposed to be red. Okay, and this is supposed to be blue, and that's blue, but not, it's a little bit off. So I'm very much inclined to take a stab at seeing if this thing is going to make a difference. So let's try it out. Now, fortunately, I left these capacitors sticking way up in the air when I put them in, so this will make it real easy to unsolder them and replace them. Problem is I don't have any 43 puff through holes, but I do have some 43 puff 0805 surface mounts, which should not be any problem at all. If I remove these, I could solder those other ones on the back of this board probably quite easily. Yeah, because these the pins are a 1/10 of an inch apart on those caps, so I can just stick them underneath here or even on the top, but I don't want to poke around in there with my iron. It'll be easier to do them on the bottom after I take out the through holes. And I think we're good. There we go. We've got two 43 puff surface mount jobbies on the back there. And the moment of truth. Here we go. Breakout. I'm not seeing it. I don't know. You might be right about that oscillator, but I'm not feeling the excitement about the colors. I'm also seeing some glitching that I'm not used to seeing. So with it running at a different speed, it may also be wreaking havoc with the pulled style logic that I use in the Z80 to check to see when there's a new frame. It is weird that it only seems to happen after various bounces. But that is the subject of the other issue that I posted here a while ago. I think I've even talked about this on my channel. Providing another way to monitor the interrupt for the VDP so we can use pulled mode synchronization. Interrupts are kind of problematic anyway for multiple reasons. And if you're running a game, you don't really care what else the system's doing. I mean, you're using up all the CPU anyway, so who cares about interrupts? You can you get a lot tighter control over the timing and so on, which would be helpful, I think, right now here. So this actually might be another clue, if nothing else. I mean, the color's not any better, in my opinion, but it is another clue towards this potential interrupt monitoring of the frame status. I think what I'm doing here is I'm missing every other frame, which is why it runs half as fast there, due to the crossing of clock domains. But I'll get into that in much more detail later. I'd love to hear your opinion on this color situation here. Color is really based on a phase angle, as I've talked about on my channel in the past, not necessarily the frequency of the color subcarrier, but those load capacitors on the crystal on the VDP do have an impact on the duty cycle and the frequency of the oscillation. So when that is wrong, there could be other artifacts that have to do with color and other things. I don't know how tolerant this capture card is as that frequency changes, is the point here, right? So who knows? If you are, an NTSC, CVBS expert, let me know in the comments below. How do I get the reds to be red on this darn thing? Thanks for watching. I'll see you next time.